Swayam Prabha. Digital India. Educated India.
So let us now discuss about the, at this stage probably you have better idea what are the different types of bioprinting technologies available and what are the capabilities of all these different types of bioprinting technologies or bioprinters. Now let us discuss what should be the capabilities of ideal bioprinter. Now suppose I want to use a bioprinter, what are the things that a bioprinter should have that I can use it for any of my applications, and so that I can freely use that bioprinter for any of my bioprinting works. Like, so first is the high degree of freedom in motion, right? Till now we have seen that the bioprinting head, suppose in case of bioprinting head can move in XYZ all directions, right? Even in case of inkjet based bioprinter also, we have seen that that print head can move. In case of laser assisted bioprinter, we have seen that the laser is moving on the surface, right? But the print head should have very high degree of freedom in motion. Why? Because suppose now mostly what happens, most of the bioprinter, they are very well used for printing on planar surface, right? So when the surface is plane, then we can move the print head like this. When the one layer is done, the print head moves to the print bed moves down, or the print head comes down, comes up one layer, and then the next layer is printed in there. But suppose when I'm thinking about translating this technology to the clinics, there most of the time I have to print directly on the wound bed. So there it would not be a planar surface, it can be a non-planar surface. If my bioprinter does, suppose I want to print on this non-planar surface, if my bioprinter doesn't allow me to print, if the printer doesn't have high degree of freedom, then it cannot print like the non-planar surface. So to print in a non-planar surface, high degree of freedom of motion is very much important. So that is now lacking in most of the bioprinter. They don't allow the print head to rotate or to move in other non-planar surface. So that is the requirement for ideal bioprinter. Other thing is I need very high resolution and accuracy. So if I can accurately print a tissue structure mimicking that native architecture or native microstructure, then I need accuracy of the printer and the high resolution, so that I can print very fine intricate details of a particular tissue cluster that can be printed. So high resolution and accuracy is another capability that is required. The printer, like now some of the printers like inkjet based printer or laser assisted bioprinting, they offer high resolution, but they what they do, the high speed but accurately printing high resolution structure is another requirement for this ideal bioprinter. Then the next is the high speed motion. Now when I'm thinking to translate this for printing artificial tissues and organs, then the print head should have very high motion or high printing capability. That is another important thing, because unless I have high printing, the printer can take time for printing. Suppose a centimeter size tissue, the printer can take some time to print it, but by the time the tissue will be ready, it will be few hours to few days the printer can take, right? So but we need a printer that has very high speed motion, so that the tissue printing time can be minimized and that can be faster. The other thing is the printing should able to dispense various bioinks simultaneously. Now suppose when I am printing for this, when I am trying to print a tissue structures, there multicellular, because all our tissues have more than one type of cells. It's a multicellular construct. So if I want to create multicellular constructs, I should have the capability of dispensing more different bioinks, like more than two types. Suppose I want to print three different cell types in particular locations. So I should be able to dispense three different bioinks containing different cell types simultaneously to print a multicellular construct. So that is another thing. So nowadays some of the printers are available where they can or they allow printing by different or dispense various bioinks simultaneously. Other thing is ease of use. Now this bioprinter should be user friendly. There should be less skills and knowledge required to run a bioprinter. Otherwise, what will happen? We have to train people. Now, training is one important component, definitely, but the skill development is another major challenge, right? So the bioprinter, if it has to be adapted, suppose this, if there should be widespread use of bioprinter, then the ease of use is definitely a common requirement for easily translating this bioprinter for different applications. Other thing is the bioprinter should have compact size. Why? Because if I use a bioprinter, if the size is huge, then I cannot keep that inside a sterile room. Suppose I have to, for clinical translation, it is required that the bioprinter should be kept inside a clean room facility or GMP facility, right? So that the tissue printing process can be done under the GMP, right? So that's why if the bioprinter is of compact size, then I need very less space. So I can keep that inside a clean room, or I can also keep that inside a laminar flow or biseptic cabinet, right? So that's why. So compact size is another important thing, so that it will not take big space and it can easily be accommodated inside a biseptic cabinet. Now, ease of sterilization. Now, for tissue printing, we know that that's an aseptic process. We have to maintain sterility. So otherwise, the bioprinted tissue can be contaminated all the time. So that's why ease of sterilization. The printer should be able to sterilize with ease. So I need not to do much thing for sterilization of the bioprinter. So that is another thing. Full automation capability. The bioprinter should be, the whole process can be automated, right? There should be very less user intervention required. So that's why this automation, some of the printers they allow is, but mostly they are semi-automatic, they are not fully automatic. But the bioprinting process should be fully automatic, and the full automation capability is there. Other things, affordability. For widespread use of these bioprinters, this is very much important. The bioprinter should be affordable, so that many of the researchers or users, they can afford the printer and they can use it, right? Versatile. The bioprinter should be able to print different types of materials, different viscosities of material, different types of cells, and different multicellular construct can be built with this or can be fabricated with this bioprinter. So that is another important. The bioprinter should be versatile in nature. But do we have all these qualities in current bioprinter? Let's see what are the limitations of these bioprinter technologies current and the current scenario. Like, what type of bioprinters we have? We have seen different bioprinting technologies. We have also seen what is the ideal capabilities of a bioprinter. Now let us see currently what are the different types of bioprinting. What are the limitations of these bioprinters? Like, there are limited variety of commercially available bioprinters. If you see, there are only very few players who supply or who actually manufacture and supply this kind of bioprinters. There are very few, right? But what we need different types of bioprinters. If there are multiple players, then also the bioprinters will become affordable. So that is another thing. Another thing is the variety of bioprinters are limited. So we don't get different types of bioprinters. That is like, suppose if we can get bioprinters having capability of printing different types of materials, then that can be an advantage. So different limited variety of commercially available bioprinter, that is a challenge, that is a limitation now. And probably in the future that can there are many now, there are many new players are coming into the market, so probably we will get more and more different types of varieties of bioprinters available. Other thing, cartesian nozzle design, mostly most of the bioprinter they have similar type of cartesian, similar type of nozzles, but for bioprinting of a particular tissue construct, what we need different types of nozzles, we need different types of cartes. So cartes and nozzle design is very important for to take the bioprinting technologies forward. So they are probably all these different bioprinting manufacturers, they have to invest heavily when they can come up with different types of nozzles. Now, size and speed of bioprinters. Now, most of the bioprinter, their size is not very compact. Nowadays, few of the bioprinters, their compact size is very compact, but most of the bioprinter, the size is an issue. Other thing is the speed of the bioprinter. These bioprinters, and the speed is limited. We cannot print tissue at a very high speed. If we increase the speed, there are other challenges. So those things are there in case of this bioprinter. The size and speed of the bioprinter is another challenge for limitation of the current bioprinter. The limited motion of bioprinting, the print heads. As I have discussed in the last slide, that all these bioprinter, they have limited motion capability. They can print very well on a planar surface. But suppose I want to print on non-planar surface, then the print head should have high degree of freedom. So that is lacking in the current bioprinting technologies, and that can be taken up in the when somebody develops a new bioprinting thing. Lack of full automation. Most of the bioprinter, they don't allow full automation. Why? Because this bioprinter, some of the process is manual, and the printing, suppose some part of the process is automatic. So most of the bioprinters, they work in the semi-automatic space. It's not fully automation, but for bioprinting, if we want to remove the user intervention from this thing, then the full automation capability should be there. Other thing is mostly the bioprinting technologies and the bioprinters are very expensive. So the high cost of the bioprinters is a deterrent for widespread usage or availability of these bioprinters. So the cost of the bioprinters, that also was should check the cost of the bioprinting technologies should be there. The other thing is this, most of the bioprinter, the resolution is not very high, except for inkjet and laser assisted bioprinting. The resolution is not that high with extrusion based bioprinting. So resolution, that is also another factor that can be improved further. So the resolution of the bioprinter can be also improved. Lack of compatible biocompatible material. Now most of the bioprinters we have now, they can use some certain type of materials, and we don't have a wide choice of materials. So that is also challenging, because we don't have the bio-ink. Also there is a limited choice of bio-ink available, but that is also an important limit. That's also one has to look after how we can widen the choice of materials for bioprinting technology. Now, because of all these things, there is a very less progress in bioprinting and tissue engineering research. Most of the research research works are limited to lab scale or lab based, and some cases like that has gone to the in vitro studies or in vivo studies are done, like animal studies are done, but nothing has gone to the clinical level because of this low progress in terms of bioprinting technologies and this thing. So if the bioprinting technology the technology limitation can be addressed, then definitely there can be a growth in the bioprinting and tissue engineering research. As I have already mentioned, that there is a very limited clinical translation of this technology. So for clinical translation, what do we want? We want the bioprinter to be available in the hospital or in the clinics, inside the hospital, inside the operating room. So where the printing tissue can be printed and directly it can be applied on the thing. But this kind of bioprinting, so this there is a challenge. There is a till now this is there is challenge of this kind of the work where the bioprinting technology can directly be used inside the OT, and then it can be done. There are a few instances, but still we need a widespread use of this bioprinting technology by printers inside the clinics or inside the operation theater, where it can be directly be used, printed, tissue can be printed, and that can be used. So all these are limitation of the current bioprinting technology, and there is a huge scope for development, improvement of all these parameters, so that this bioprinting technology can be widely used for different tissue engineering and regenerative medicine research. So with this, come to the end of this lecture. Thank you very much for listening. We'll again meet in the next lecture. Thank you very much.